It's now time for moles part 3, and this is when we can handle compounds and not just elements. So we're going to start with an ionic compound. We have a little vocabulary to deal with. Copper sulfate is ionic, and let's get the formula for that. So copper is Cu, and the Roman numeral indicates a positive 2. Sulfate is a polyatomic ion, SO4, and that has a -2 with it. Okay, then +2 and -2, those balance out already, so we don't need to crisscross any of the charges. So that's the valid compound right there, and we'll put a solid there. Now this is an ionic compound, so what does that mean? Well, the sulfate polyatomic ion actually looks like this. Here's SO4. And the copper +2 is attracted to the SO4 by plus and minus interactions. So it's an ionic compound as the copper +2 is attracted to the SO4. And it's therefore called a formula unit. So the smallest unit of an ionic compound is called a formula unit. Now, why is that so? When we dissolve this in the water, it releases a copper +2 aqueous ion, followed by a sulfate SO4 -2 aqueous, and they separate because water will, tear down the crystal and pull these ions apart and drag them into the aqueous solvent cages as we described before. So because that doesn't stay together, we call this a formula unit. So that's all just vocabulary. How do we deal with ionic compounds and the mole? Well, you're going to see a very similar pattern. Let's take a look. How many moles is 12.5 grams of copper sulfate? Well, here's what copper sulfate looks like. And if we look at our triangles here, we want to know moles, so I cross over moles. And it says then to take mass divided by molar mass. So you see there's really no difference in terms of how the moles are calculated. But let's go back to copper sulfate. We do need to get its molar mass. I see that there's 1 copper, and we're going to add 1 sulfur plus 4 oxygens together. So if we look on the periodic table, copper is 63.5. And we have 1 sulfur. Sulfur is 32.1. Plus, then we'll have 4 times 16.0. So that would be 63.5 plus 32.1 plus 64.0. And that has a grand total of 159.6 grams. So now if I want to calculate my moles, I'm going to take the mass given here divided by that molar mass. Let's calculate that now. So I'll take 12.5 divided by 159.6. And that turns out to be 0.0783 moles. So see, calculating moles is really no different for compounds. We just have to get the molar mass first. Now, what was that business with the formula units? Well, when we do moles for compounds, we do have 2 choices, but they're calculated the same. It's just vocabulary again. Since this is an ionic compound, the individual unit is called a formula unit. So we want to know how many of those formula units are there, and that's going to be a big number. So if I want to do formula units, I'm going to X out this box here, and it says to take the moles and multiply by 6.02 times 10 to the 23rd. So I'll take our answer from above, 0.0783, and I'll multiply that by the 6.02, and that gives us 0.471, and remember to add the times 10 to the 23rd, and we abbreviate that F period units for formula units. So this is kind of like the atoms, but now we have a copper sulfate formula unit. So there's lots and lots of those little tiny things. So inside these crystals here, there's lots of atoms that are joined together now. So we're not just solving for individual atoms, we're solving for groups of atoms that make up the compound. And that's what we mean. Let's go ahead and do a covalent molecule. Again, glucose is a great example for that. Its formula is C6H12O6. And of course, that's a solid. Okay, but this is a molecule. Everything is covalently attached to each other. When that dissolves into water, the whole thing goes together. So C6H12O6. And we'll just put an AQ next to that. So since the smallest unit doesn't break apart and it's covalently bound, we're going to call that a molecule. Now again, that's just vocabulary. Now each individual one of these things is going to be very tiny. So it's like groups of atoms. And we are going to solve for those in this fashion as well. So how many molecules is 33.4 grams of glucose? When we look at our triangles, we've got mass here. Okay, our dilemma is we can't go directly, from grams to molecules. So we pause. Let's go back. Okay, how many moles is that first? And then we'll go back and solve for the molecules. So how many moles is 33.4 grams of glucose? I can do that. Okay, so I cover up the moles. It says to take mass divided by molar mass. Well, that means we have to get the molar mass. So we have, again, C6H12O6. So that's going to be 6 carbons plus 12 hydrogens plus 6 oxygens. So it's 6 times 12.0 plus 12 times 1.0 plus 6 times 16.0. And that would be 72.0 plus 12.0 plus 96.0. And that gives us 180 grams. So now we take the mass divided by molar mass, so that's 33.4. And we'll divide that by 180. Okay, and that gives us 0.186 moles. Now that we got ourselves in the moles, we can go back and solve for those molecules. So right now we've got molecules that we want to find, so I'm going to X this one here. And it says to take the moles multiplied by the 6.02 times 10 to the 23rd. So that's 0.186 moles that we solved for before. I'll multiply that by the 6.02. And that gives us 1.12. And we'll add times 10 to the 23rd to that. And that's going to be molecules. So notice how inside these crystals here, there's lots of little tiny units of molecules in there. They're atom size, groups of atoms that are together. And that's why that's such a very large number. And that's how we handle solving for the moles and molecules and formula units. But just remember, mass has to go to moles first before you can go to either formula units or molecules.